Hello everyone, Ramya, Assistant Professor of CSE Department from Rohini College of Engineering and Technology, subject code CS3452, Theory of Computation, Unit 5, topic PNP and NP complete problems. Objectives: to understand the concepts of P and NP complete problem. PNP and NP complete problems. Here it can be solved in polynomial time or called tractable. Here the problems cannot be solved in polynomial time or called intractable. There are several reasons. First, we cannot solve arbitrary instance of intractable problems in a reasonable amount of time unless such instances are very small. Second, although there might be a huge difference between the running times in big O of P of n for polynomials of drastically different degrees, where here the P of n is a polynomial of problems input size n. The next one is the polynomial functions possesses many convenient properties. In particular, both the sum and composition of two polynomials are always polynomials too. Then the last one is the choice of this class has led to a development of an exhaustive theory called computational complexity. Next, we are going to see the definition for class P. It is a class of decision problems that can be solved in many polynomial time by deterministic algorithms. This class type of problem is called as a polynomial problem. That means it can be involved in polynomial time as the set that computer science theoreticians call P. Then the next one is the formal definition includes in P only decision problems, which are problems that means yes or no answers. Now here we have some of the examples, that is searching, element uniqueness, graph connectivity, graph acyclicity, primality testing. The next one is we are going to see the restriction of P to decision problems can be justified by the following reasons. The first reason is it is sensible to exclude problems not solvable in polynomial time because of their exponentially large output. For example, generating subsets of a given set of all the permutations of n institutions. The second one is it's an important problem that are not decision problems in their most natural formulation can be reduced to a series of decision problems. It can be easier to study. Here, for example, instead of asking about the minimum number of colors needed to color the vertices of a grammar, coloring of the graph's vertices with no more than m colors for m equal to 1, 2. That later is called the m coloring problem. The last one is every decision problem cannot be solved in polynomial time. Some decision problems cannot be solved at all by many algorithms. Such problems are called undecidable as opposed to decidable problems that can be solved by an algorithm. Otherwise it is called as a halting problem also. Then next we are going to see the non-polynomial timing algorithm. That means here also it is also one of the important problem. Here the no polynomial time algorithm has been found. First one is Hamiltonian circuit problem. That means whether the given graph is a Hamiltonian circuit, otherwise the path starts and ends at the same vertex, means it should passes through all the vertices exactly once. The next one is a traveling salesman problem. Using this, you can able to find out the shortest through n cities with known positive integer distances between them. The next one is knapsack problem. Using this, you can able to find out the most valuable subset of n items of given positive integer. That means weight and values that fit into a knapsack of a given positive integer capacity. The next one is a partition problem. Using this, whether it is possible to partition them into two disjoint subsets with the same sum. The next one is bin packing problem. That means given n items whose sizes are positive and rational numbers not larger than 1. Put them into the smallest number of bins of size 1. The next one is graph coloring problem. It find its chromatic number. It is the smallest number of colors that need not to be assigned to the graph vertices, so that no two adjacent vertices are assigned here. The last one is integer linear programming problem. Using this, you can able to find out the maximum or minimum value of a linear function of several integer valid variables subject to a finite set of constraints. Then next we are going to see the definition for the NP class. That means it is the class of the decision problems that can be solved by non-deterministic polynomial algorithm. This type of problem is called as a non-deterministic polynomial. That means P is the subset of NP. Here most decision problems are NP. First of all, this class includes all the problem in P. For example, if it is true, because if all the problem is in P, we can use the deterministic polynomial time algorithm. Then only you can able to solve the verification stage of a non-deterministic algorithm. Then simply ignores the string as generated it is non-deterministic. So only here we have the halting problem. On the other hand, is among the rare examples of decision problems that are known not to be in the NP. Then here we have some of the definitions for D. That means a decision problem D is said to be a polynomial incomplete if it is hard as many problem in NP. That means it belongs to the class NP. Every problem in NP is a polynomially reducible to D. That means it is very closely related to decision problems or polynomial reducible to each other is not very surprising. For example, let us prove that the Hamilton circuit problem is a polynomial reducible to the decision version of the traveling salesman problem. Thank you.